Hello everyone, I am Ninad, I'm a software engineer. So this is day 2 of me trying to solve Striver SDE Sheet. So the motivation behind this was pretty simple. Wanted, I used to do a lot of DSA back in my college, and uh, I basically lost touch with it after I started doing my job. So I'm trying to uh, get back to the level that I was in college in DSA. And not only that, also I'm trying to improve my presentation skills, my explanation skills, and uh, yeah, we're trying to get rid of my anxiety when I'm presenting or explaining something. So yeah, let's start. Today we are going to tackle the second problem, that is passive triangle. So yeah, I'll be doing it on Leap code, and I'll be using Python as the language because that's my primary language that I use on a daily basis. So this is Pascal's triangle. So it's given an integer numbers, return the first numbers of a Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers that we have already shown. Okay. So now I see this. On me. So I'm approaching this. So I just saw a pattern here. So we can forget when n equals to 1, rows equals 1, at that time it will always be 1. But for all this, I can see the pattern that the starting and the ending element is always 1. I think that is a default. And then now for this third element, we can see that it was the uh, sum of the elements of its previous level. So 2 is sum of 1 plus 1, then 3 here is 1 plus 2, this 3 is 1 plus 2. So we can say that, okay, this was the first level, this is the second level, this is the third level, and this is the fourth level. Now, what we can say is for this 3 in the fourth layer, it is a sum of this 3 is at index 1. We can say that it is a sum of the elements at index 0 and 1 at in the third level. This is the sum of elements at index 1 and 2 from the third layer. So we can say that each element, if we leave this 1 and 1, these are the defaults at the start and end. This 4 is at the first element. So this 4 is at index 1. So we can say it is a sum of the values present in its previous level at index 0 and 1. So we can say, let's say for any element that is not this starting and ending element 1, let's say the element is at ith index, we can say that it is the sum of elements from the previous level which are present at I minus first and ith index. So that's my approach, and that's how I'm going to generate the solution. So I think if now, right, why can't I type? Yeah, why? I don't know why. Okay. So it's straightforward that if number equals 1, then you can directly return a list of 1 because that is the value. Else, now uh, we know that the starting and ending element will be 1, so we can just, let's say ANS is our final list. We can say that ANS equals to list. So why I'm not doing this is something that I learned. So there are two ways of writing this. We can write it like this or like this, right? I mean both ways is fine, but this is more of a conventional way because it lets us know that it is a list. It is this improves basically improves readability, and that is very important when we are working in a corporate. Also, this will also fetch some brownie points when you are solving any list related questions during an interview. So s equals list, we know the first element will be 1, so we just append it as 1. Then now for every element uh, we'll need to do it till num rows. For I, so we can say for I in range. So if number is equals to, it is already sorted. We are concerned when number is equals greater than, when number is greater than equal to 2. So for okay, so for I in range, we have already one here. We already appended one in ANS. Okay, sorry, they should be like this. I'm so sorry. That is the initial. That is the first level. Now from second level onwards. For I in range numbers minus 1 because we have already fixed the first level. Or you can say, instead of doing this, 1 to numbers. It's the same thing. It will start from 1 and end with all numbers. I'm doing this so that I can keep track of the level more easily. Yeah. So now we know that the first element of each level, let's say level is also list. That is the list. This is the list. This could be the level list. This is the level list. Then this is the level list. Yeah, I think for yeah okay, level list. We know that the first element of that list is always be 1. Now we know that for each level. Now we iterate for j in range. So let's see when it's the level at the first index. So in the output, when we are dealing with the level at the first index, we see that in the middle there is no value, there are 0 elements. If we are dealing with the level at the second index, that is the third level, then there's exactly 1 element in between. If we are dealing with the level at the third index, there are exactly 2 elements. So we can say that we have to iterate only for the level number, that is I minus 1, because we only want that much elements. So we know what is going to come. You can directly do the level dot append. Yeah. 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 Okay. So we know that there will be I minus 1 elements, right? So this is the level at first index. There are no elements. This is the level at second index. There is only 1 element. This is the level at third index. There are 2 elements. That's why we have kept it as I minus 1. I is the level at I index, and that's why we are iterating until I minus 1. Okay. Now moving forward, we did level to append 1. Yeah. So one more thing that we can do, we also know that for in each level. So this is the level at the second index. We know that there is only 1 element, and we know that its index starts from 1. For every element, the index starts from 1. So what we can do simply here is we want to iterate via the index. So we do here 1 comma I. Now to explain exactly why 1 comma I. Yeah. So we have established that this I specifies that we are now uh, we are now at the ith level. We are now at the level that is at the index I, right? So for this level, this is at the index 2. This level is at index 1. This level is at index 2. Yeah. So basically, this level we know that okay, this is the level at the index I, and then in between we fill I minus 1 elements if we ignore the ones, right? I minus 1 elements, and its indexes start from 1. So starting from 1 and we want I minus 1 element, so we can just say 1 comma I, because then that gives us I minus 1 elements. And we know that we have to append, we can say ANS of I minus 1, values of position j, values of position j minus 1 plus ANS of I minus 1 in j. And then at the end we do level dot append 1. And then at the end we do ANS dot append level. I wish the stream is not lagging. Let's see. I just increase the performance of the GPU just thinking. I just wish that there is no fan sound because I have put it on max and now it goes crazy. Okay, let's recap what we have done here. Yeah. So we know that for each level, the first and the last element remains the same. That is the one that remains constant always. That's why we yeah, the first and the last element remains one. And now we also know that the first element will always be a single one element list, that contains one. So ANS is our output. The first level will always be 1, so we have to fit as 1. Now from the second level, that is the level at index, you can say I, we know that the first and the last element in that level will always be 1, and then the middle elements are basically the sum of the elements from the previous level. So what we do is we iterate uh, for the number of rows that we have to print, number of levels that we have to print. Why we are doing it one command macros? Because we already added the first level. Now we start from the second level, that is index 1. For each level we create a empty list. Now we know that the first element will always be 1, first element will always be 1, the last element will always be 1, last element will always be 1, the first and the last. Now this is the middle masala. So this 2, this 3, 3, this 4, 6, 4, these are basically uh, the sum values from the previous levels. How we are doing it? Now we know that we are on the ith level. This I is not the number. This is an index, the index of the level. So this, even though this is the third level, this is an index 2 in the output. So for this level, the ith value will be 2, not 3. Yeah. And then we have to fill the middle part, that starts from the first index. And we from the first index, and then we can say that for every like for level at the ith index, there are exactly I plus 1 elements there in there, right? These are I plus 1 elements. This is at level 0, 1, 2, 3, and there are 4 elements. So I plus it contains I plus 1 element. But we are only concerned about the elements in the index 1 till I, right? So that's why we are doing for J range 1 till I, and then we append the sum. So this 3 is basically the sum of 2 plus 1. That is in the previous level. 2 is at jth index, but 1 is at j minus 1 index. That's why j minus 1 and j. And then at the end we add this the 1, and then in the answer we append a label. And then we return it. We return the answer. Right? Oh, no. Oh, this one. Yeah, this is a list of it. So I missed it. Using what is supposed to be generated. That was supposed to be generated, not that. You see, we are getting. I'll submit the code. Starts nice. Okay. Now uh, moving on to the next question. Okay, we didn't discuss the time complexity. When the constraints are very low, 30, we can do 10 raised to 4 solution also, but we don't want to do that here. Yeah. Okay, so the time constraints, right? This is a for loop that runs till number rows, and this is a for loop that runs till the middle part of the. So we can say that this is a numbers into numbers that an n cross n solution. The time complexity for this will be n cross n, and it's self-explanatory, right? Because we want to print each of the element, and there are n rows, and then for each row it's increasing, it is increasing, but yeah, for each row the number of columns is equal to the row number, you can say. It's at the end it becomes n square complexity. So yeah, that was Pascal's triangle. Now let's move to the next question, that is next permutation. Let's read the question. Permutation of an array of integers is an arrangement of its number into sequential linear order. For example, for array 1 to 2, the following are all the permutations. So, I'm very bad with permutations. Sorry about that. I'm very bad with permutations. I don't know how I'm going to answer this. Let's see. The next permutation of an array of integers is the next lexicographically straight permutation of its integer. Only for the permutations of the array are sorted in one container according to the lexicographical order. So the next permutation of the array is the permutation that follows it in the sorted container. Okay. Okay. The next permutation of 1 to 3 is not equal to self-explanatory. Then fine. You have to find the next permutation. Okay. I am bad with permutations, and I can see that I'm going to struggle with this question. Let me think. Oh, what solution can be? created. Let me think of an approach. The replacement must be in place. So in place basically means that we should not use any extra space constraint. You should do it in the same array. And time complexity is uh, non-stop learning. Just give me a minute. Okay, so it goes in a circular order. For 3 to 1, it becomes 1 to 3. Let's write and see. For 1 to 3, it will be 132. So for 132, it will be 213. Right? See here, 213. Okay. Whenever I see permutations, my brain goes into ईशान mode. नंबर उड़ रहा है, कैसे हो जाता है? One, two, three becomes 1 to 120 becomes 41. My brain start working, but I'm going to solve this irony test today. I always try to economize of permutations, not today. Permutations are like board exams, answers that we write in board exams. We write the same sentence in different permutations, active voice, passive voice, every type of voice we use to make the answers lengthy. You know, yes, I'm not able to think of anything yet. and I'm thinking of why I don't know why I'm thinking of binary tree here. And basically overfilling the question. It would be something simple. Becomes 1 to 3. How, how are we going to keep track of this? Is 100. 120 becomes 132. 132 becomes 213. 45 marks. So we don't have to return anything. It's in place right there. Swapping. And if it's sorted, then we swap the last button. This is not supposed to be so tough. Why am I not able to think of anything? 3 to 1 to 3, 1 3 2, 3 to 1, 1 to 3. Okay. Okay, I'm not able to think of anything. Let's check the editor at this point. And stupid. I mean, this I know brute force we can do, but this is not a good approach. Single pass approach. Yeah, yeah. If it's in descending order, like if it's 3, 2, 1, right. Yeah. If it's 2, 2, 1, then we know that everything will be sorted. That is 1, 2, 3. We need to find the first of two successive numbers a and a of I minus 1 from the right to satisfy ai is greater than e minus 1. Now no rearrangement for right of can create a larger permutation. Okay, so this is the answer. We need to find the first pair of two successive numbers ai and a of I minus 1 from the right to satisfy ai is greater than a of I minus 1. So in this case ai should be greater than a of I minus 1. In this case it will be 3 1. Now no rearrangement to the right of ai minus 1 can create a larger permutation. To the right, create a larger permutation since that's a very consistent numbers in descending order. Okay. Yeah, 3 comma 2. It's going to rearrange the numbers to the right of. Now no rearrangements to the right of I minus 1 can create a larger permutation since that's a very consists of numbers in descending order. Just we need to rearrange the numbers to the right of ai minus 1 including itself. Now what kind of rearrangement will produce the next largest number we want to? But he says now no rearrangements to the right of a of I minus 1 can create a larger permutation since that subarray consists of numbers in descending order. Oh, right, yeah. I mean that is true. Thus we need to rearrange the numbers to the right of. Okay, got it. So okay. So basically we are saying that we need to shift this or shift everything of this to the right. Now what kind of rearrangement will produce the next target? Now we want to create a permutation just larger than the current one. Therefore we need to replace the number of I minus 1 with a number which is just larger than itself. Amongst the numbers lying to its side, say AG, E of G. So in this case just larger than 3, that will be to its side, that will be 2. No, just larger is nothing. We can take an imaginary case like 1, 4, 2, 3. The answer should be 2, 1, 3, 4, I think. Right? No. It should be 1, 4, 3, 2. Yeah, better. That should be the answer. Here in this case, which just larger than. Okay, here AI is greater than AI minus 1. So let's take 4, 3, 1. This will be a better example. Now the answer should be 2, 1, or we can do like this 1, 3, 2, 4. Now the answer will be 1, 3, 4, 2. Okay, so they are saying that they want to create a permutation. They are going to rearrange the numbers to the right. So where they found A this condition, right? Let's take another example, the better example. 1, 4, 5, 3, 2. This is a better example. Now the answer is 1 comma. It will be 5 2 3 4. 5 3 2, so 5 should be there. Yeah, I think this should be 1. So we will find this term here 4 comma 5. Our I is 5 e of I is 5, e of I minus 1 is 4. We want to arrange the numbers to the rights. We know that okay, number to the right of a of I minus 1, this cannot create a larger permutation, right? So we want to rearrange this, including we rearrange this whole thing. Get a permutation just larger than the current, before we need to replace number. Replace this with the number which is just larger than itself, so that is 5. So this is the answer, and we are doing this 1 comma 5 comma 4 comma 3 comma 2. So AJ, we swap the numbers A and AJ. Okay, we swapped it. We now have the correct number at index I minus. We have a correct number at index I minus 1, but still the current permutation isn't the permutation that we are looking for. We need the smallest permutation that can be formed using the numbers only to the right of A minus 1. Therefore, we need to place those numbers in ascending order. So whatever these numbers are, we put it in ascending order. But recall that while scanning the numbers from the right, we simply kept decrementing the index. And recall that while scanning the numbers from the right, we simply kept decrementing the index until we found a pair AI and AI minus 1, where AI is written AI minus 1. Thus, all numbers to the right of A minus 1 were already sorted in descending order, right? Furthermore, swapping didn't change. Therefore, we simply need to reverse the numbers following AI minus 1. So we need to reverse these numbers. Okay. I mean, this is also kind of like implementation. I mean, okay, I thought that there would be some smart way of solving it. They're basically creating cases and then solving those cases. Okay, fine. That was very anticlimactic. I was expecting something smart. I think yeah. I mean, this is easy to solve if all the numbers are in descending order, right? How are we going to check it? Okay, you can check it. You have the list, right? I don't want to solve the list. What do I want to use? You can just put a check. Delta equals reverse. For reverse, we'll do rev equals not rev. We'll do reverse like this equals false. No, we'll initially assume that it's true. Then we will iterate the whole list. Let's say n equals length of nums. Length of the list for I in range, not n. We will check it n minus 1, and we will check it a of I is anywhere a of I is less than a of, it's a permutation, right? So no two elements will be same. If we found that, sorry, not a of I, we found that anything is in ascending order, that means that the numbers are not sorted in the descending order. So we say our reverse equals false, and we break the loop. Now here we just do reverse. We do print, no, not print. We do nums dot sort, and we just put it as it is. Else, now we come to this condition. We come back to these conditions, right? Yeah, but then here basically we iterate from right. Minus 1 comma minus 1. We don't want to go to the last one. Yeah, we check if a of I is greater than a of I minus 1, right? That is, if we find anything in sorted order. If we find, then we basically need to find the next nearest greater to a of I minus 1. And if we can't find it, what happens if we can't find it? So in the case of in the case of 1 comma 4 comma 3 comma 2, we make it as 1 comma, we do it as 4 comma 1. Right, because in that case this becomes our a, and this is our a minus 1. This, because this becomes 4 comma 1 comma 2 comma 3. First, initially we will swap 1 with 2, so this will become, we will swap it, yeah, we will swap it, so this will become 2 comma uh, 4 comma 3 comma 1, and then we will reverse the order towards the right of that. So this becomes 3 comma 1 comma 3 comma 4. That's the final answer. So what we do here is, if we find this, we say that our breakpoint is, and we will find this because we had made sure that it is not a reverse order, so we can say that we can keep a variable called breakpoint is I minus 1. Yeah, initially breakpoint equals 0. Yeah, I minus 1. So now we have our breakpoint. We want to swap it with the next biggest value towards its right. So we do for I in range. From breakpoint we will start till we will go till n, and if we found anything that is good, and like, yeah, if nums of I, yeah, I did it. I am stupid. I'm very stupid. This should not be. This should be nums. If we do nums of I, we found that nums of I is equal to nums of next nearest means plus 1. Will next nearest will always be plus 1. What if plus 1, that plus 1 is already towards the left, and that causes an issue. So basically, in this range, breakpoint plus 1 till n, you want to find a, because all these are already there in the decreasing order, right? For we said we have BC 1 4 3 2 1 4 3 2, so 4 3 2, these are already in descending order. Yeah, because we are checking till this now, so everything will be in descending order. So we can, I'm stupid. We can just directly swap breakpoint element with the last element, because we are checking here if we find anything in sorted order, and if we do like till breakpoint we did not find anything in sorted order, that means everything is in descending order. So that's why we just swap. So we can say nums of breakpoint comma nums of -1 equals nums of -1 comma. I like Python swapping. This is very simple. You don't have to use a template. Now we swap it with the correct value in breakpoint. Now we just have to sort everything ahead of breakpoint. So we can maybe do this like this: nums of breakpoint plus 1 till end dot sort. This should work. Let's see. And I'm very smart because what did I do? Say it clear here. What do you mean nums is not good? What is this? Yeah, I'm very smart because I did it up to function definition. Come on now. Why am I using A? See, that is my old habit of using A. I should use nums. And wow, this is wrong. I have one, this one. print here. Will it print? Yeah, it prints here, so it goes into this. So my else logic is wrong somewhere. Let's see, here the breakpoint will come in here only. The last element is the breakpoint. No, breakpoint is 2, sorry. 2 is our breakpoint. And we swap 2 with 3, so it becomes 1, 3, 2. Then we okay. Let's print now here. Let's see what is happening. Yeah, because we are not breaking. We should break here, right? Once we get a breakpoint, right? We get the first breakpoint, then we should break. I forgot to break it. Yeah, now it's getting good. Now we submit. And the wrong answer. Very nice. So here our breakpoint will be 0. Our nums. I'll just copy it around this. Put it here. Just run. Yeah. So what am I doing now? Let's see. Our breakpoint should be 0. Then after swapping, it should swap it with 2. 1 with 2. Now this becomes 2, 3, 1. And then this sorting is not working. I think this is not the correct way to solve it, but let's see. Maintenance command breakpoint. I was just going to say about breakpoint. Let's run this. 0. It should sort on 1 till end. But it's not doing that. Because there will be some other way to do this. So what we can do num equals nums will breakpoint plus 1 plus this one. Run. Saying this is none type. Why this is none? Ah, no, but it should contain a Today we sorted it, so let's try sorted. Why? The same thing. So does it work like this? I'm not sure. I should know this, but that's what does not take place this time. Let's search how to sort in a range in list. Oh my god, oh my god, my laptop is going to. I mean, we tried this only, right? We tried this only. I tried that only, man. Yeah, this is frustrating. Okay, it has to. Oh, okay. Right, I'm doing slicing also. Then what is the issue? I need to this comma. Yeah, this is 2, this is 1, 3, then why? Why? So should I do like this? Nums equals none. And then that. Yeah, this will not work now. How man? This is not possible. Oh, I can do that. Maybe. Okay, I would like to try this approach. Voila. Nice, nice, nice. Yeah, but I got to learn something that I can do sorting in a range like this. So that's a plus point. When it runs, ultra submitting. Okay, it's wrong answer. I am I am so bad. I, I'm really bad. Now what is the issue, man? Usually this is permutations are like if else case based. We have to do it case based and it becomes very hectic, very complex, and I hate it. Can we get a test case? Now it's 231. Yeah. So breakpoint should be 0. Yeah, it is 0. Then oh, because one is not the next biggest. Instead, 3 is the next biggest here. Okay. Then for starting, right, what we can do is we can start the loop from breakpoint in range, breakpoint, not breakpoint plus 1 till we will go to n, and then we will iterate till we are finding, because it will be after the breakpoint everything will be in the decreasing order, so we will search till we find something that is greater than that is still greater than our break than the element at the break, because higher than it. So if nums of I is greater than nums of breakpoint, swap index equals, initially we keep the swap index as breakpoint only. Swap index equals I. Yeah, so you see, after the breakpoint index, after the element of breakpoint, everything will be decreasing order. So we will iterate till find something that is greater than the element at breakpoint. Because after that, so once you start finding something less than it, the other values will also be less. That's why we find the last value which is greater than the element at the breakpoint, and that will be just greater than it. No, not indeed. I want to swap. So the same thing in terms of breakpoint. Common nums of swap index equals nums of swap index. Should work now, please. And this should work now, please. Yes, nice. Okay, so 2 more questions solved today. That is a production. This is nice. I'm really enjoying this. I mean, I used to do this. I was thinking of doing this Striver Sheet anyway, and then I decided to do streaming because I mean, I don't know. I was feeling lonely. I was very lonely. mm, Trying to solve this alone. I thought maybe I don't know. I don't care if someone is watching or not, but it's fun. Something new. It's exciting, and I'm enjoying this. Like the just the thought that someone might see it, and they are going to cringe because I am very awkward at times, and I say very stupid. I like this. Someone in the future solves this easier. Tries to solve along with me. That's a plus point. Let's see. This is just early days. I was really enjoy it. I just can't wait to come home from office and start streaming. So this is like adventure. This is like a job. Like, you feel the tension, you feel the anxiety, you feel the excitement. That okay, this is something new. People are going to see this, so I have to be like I can't just half-ass this thing. I have to be on point. I have to do everything thoroughly. That helps me in maintaining my discipline as well. So yeah, that's really good. So that's it for today. Tomorrow we'll start getting algorithm. And I'll do. I'll definitely try. This is so fun, so much fun. Yeah. So anyone has joined, I can't see the chat. I don't have a photo set. I'm new to streaming as well. So thank you for joining and for being a part of the stream. Bye. Good night.